Good afternoon. It's 12 noon, real time, East time. And you may notice my voice is a little off. I got a sore throat and a wicked ass cold. So I may have some coughing attacks as we're going through. I'll mute my mic so you don't have to hear me cough my brains out. Okay. But other than that, we will do our lunch and learn today, the Dorman Lunch and Learn. We're using the AES UScope. Okay. We're going to talk about a couple of things on a scope. And how many of you out there use a scope? Type in the letter S if you use a scope. Okay. I'm G. Truly, your instructor, I should say. But again, hopefully my voice holds up. So what we're going to cover, updating your scope skills. Very important. Now, sometimes you don't want to take home that big scope, or maybe you're a tech at the shop. This U-scope, as you're going to see, is a very little one. You put the camera on at a second there. You see that little thing? Look at my finger. That's my pinky near it. Okay. So it's a little scope. It's really great. Some of you may have it out there. It's real good to practice on so you can get your skills up. There's a lot of videos online, a lot of description. There comes with a manual. It comes with a bunch of stuff. You can buy the master kit. So we'll go through some of the things that you can do. We're going to look at injectors, cam crank, TPS, O2 sensor, intake air, and BTS. We'll try to get to ignition or more, but I think the way I'm feeling, we'll do what we can do today. I will add some other stuff to this video at a later date. So when you see it go up on the Dorman thing, I'll just re-edit the video and we'll put it up there for more information. And before I forget, I want to wish you and your family a very happy Thanksgiving. We'll be back next month for another Dorman Lunch and Learn. And by then, my voice will be back. I'll be better. Okay. So using a lab scope, this is important. If you can use a test light, okay, because a lot of people are afraid of scopes. A scope is a test light on steroids. That's all it is, right? You can use a logic probe. I don't know how many people use logic probes, a meter or a graphene meter, and then a scope. So we're going to show you that today's vehicles that we're working on are advanced pieces of machinery. You're not going to always get the answer with the number one tool being used in the country, the scan tool. Scan tool is everything, right? So we're going to show you with this little scope how maybe you could practice doing some things. We'll walk you through some of the features on the scope and take it from there. Okay. So one of the things you need to look at is the scope reads voltage vertically. Horizontal is always time. And most of you probably know that. But when we pick the time per division, if I pick this as 10 volts per division and I start here, then I got 10, 20, 30, 40, 50, 60, 70, 80 if it was an 8 graduate scope. Okay, in other words, 8 boxes there. Time is 10, because we can have scopes 8 by 10 or 10 by 10. Most new scopes nowadays are 10 by 10. That means you would have 10 divisions up, 10 divisions across. So it's a simple thing with a scope that we'll kind of look at and go through. Trigger is the big thing. Trigger steadies the sample rate. So if you want to see a steady type of thing, we have trigger. I like doing trigger at half the voltage. You see, this is a 2-volt signal here, triggering at 1 volt. And then there is slope. Slope could be positive, going from negative up, that'd be a positive slope, or from positive down, which would be a negative slope. So when we look at a fuel injector, what type of slope do you think you want to set for fuel injector? Is it a positive slope or a negative slope? So put P or N. I had to think about that twice. P or N in there. Let's see what you come up with. And I know we got a little bit of a delay. Okay, so P and N, and thank you guys for the happy Thanksgiving back. We do appreciate all that. See all you people on there. We got anything coming up? Okay, positive. N. Yeah, what we want to do is actually drop the voltage down. I'm going to draw this up here actually on the board. So here is our line of voltage for a fuel injector, right? Then it goes down, and then it comes across, and then it peaks up. So you're going from a plus voltage to a negative voltage. So our slope would be like the letter Z. It would be a negative slope. Okay. So Doreen will just come in on that a little bit. So again, you're coming out system voltage, 12, 14 or so volts. The computer's pulling it down to ground. Then when you shut it off, there it peaks off, right? That's the injector on time from here to here. That would be a negative slope. Okay. That would give us the steadiest picture reading of that particular setup. So trigger could be used. Certain things trigger is good on, and other things trigger may not be so helpful on. Okay. We're going to show you a couple of things. This also is the signature, just like you see here, of the signal. See that signature of the signal? Well, once you stare at the signature of the signal, you may not find a dropout. Excuse me. You may not find a dropout. Why? Because at the sampling rate it's actually sampling out, you may not see that. So I'm going to show you a little trick that I like calling the picket fence. Okay. The picket fence is meaning rather than just seeing you got 1, 2 complete cycles, you're going to see a bunch of them. Because once I see them going all the way down the ground, and I'm going up to my 5-volt reference, or in this case, 2-volt reference, right? Once I see that, I may not see a dropout. So I'm going to show you how to do the picket fence. Any questions on that? We're going to do it live now before we get back to any slides. And we got to take some time here. We're going to switch over to a different camera. Okay, so now we're on the UScope. This is the UScope. This is a great little tool. There's a little power button right here to put it on. Watch how quick this thing boots up. So you can see AESwave UScope comes up. And we are connected to a test board here. This test board is off my old Fluke 98. And there are many of these that you could purchase on the internet. Fluke 98, obviously not around anymore. Snap-on sells a little test board as well for a few $100. Or you could purchase this one here from Automotive Test Solutions, okay? And this is probably a couple of $1,000 board or so. Check their website for the actual price. We'll be using that, but we're going to start off here with something inexpensive so you could see that the UScope could actually help you tune your skills in using a scope, okay? So we're on an injector waveform, but it doesn't really look like the injector waveform. So what we're going to do is go through a couple of things here. You can see our lead set is connected right here on the scope. I have power plugged in here, and how you know you got power plugged in, it's going to say USB, or if I unplug it, it will give me my battery level, okay? It's telling me my probe calibration. We'll talk about that as well, 1-to-1. Our voltage, our per division, our frequency, we're measuring something here. On the bottom, we have volts per screen. This is a 8 grid up and 12 grid across. You heard me right. 8 up, 12 across. Most scopes, old scopes of years ago were 8x10. Most scopes nowadays are 10 vertical, 10 horizontal. We have our time, and we can control all this by pressing these buttons here. And you can see how it highlighted our position, our trigger range here, auto, our level, our slope, invert, and our menu. Since we're on our menu highlighted, we have keys here. These are arrow keys that you just seen me use. I can go back with this. You'll see invert lit up, but I'm staying on menu. This is our up and down keys. I'm going to hit OK, and when I hit OK, I can see there's a menu here, vertical. So let's hit one of these keys here and go into this voltage per division, ground, vertical position, invert, reference V voltage positive, and probe calibration. So we'll be seeing that. Now we're going to get out of that, and that's how to get to every menu. We hit OK. We hit OK again. We go down to horizontal. Horizontal gives us time per division or horizontal position, meaning you can move it this way or that way. Let's use horizontal position since I want that more that way. So I go here, and then I can use my soft key, and I moved it over, okay? Now I can see that I am about one grid. Now once we're done with that, we could hit that, get out of it. Here is our trigger part of the menu. So you got trigger mode, level, slope, window, and horizontal position. Some things are repeated in menus just to make life easier. Here are some presets. So if you wanted to go to fuel injector, to be under an actuator, right? We select actuator, and you notice there it's an idle control solenoid. I'm going to get injector that's pulse width modulated. That's signal ground. That's the one we're going to select. Okay, so we're going to hit the button there, and now we're set on injector ground. We got to play with some adjustments here, but it'll give you a picture. Going back to menu, we can see that we can go down and set curses, and we'll use this in a little bit. Our curses are off right now, but to give you an example, let's go down and put the vertical curses on. And you can see white dots here and white dots there. Those are the vertical. I'm going to shut them off for now. We go back in. We go down to meters, so it can give us frequency, as you can see here. We can go down, select duty cycle if we want, okay? We can see minimum and maximum, which is pretty neat. It's telling me right here, my voltage is 35 volts, and my minimum is like just about 0. So that's pretty neat. Let's go back in, go down. You can save files. You can save them as bitmaps. There's a card under here that saves all the files in there, or you can save the user setup. And going back, we got a bunch of options on the bottom. And you can see here sample rate. We go up to sample rate. We can go fast or normal. I'd move it on fast. Try to grab what you can. Okay. We have other factory resets, all that. And we got grid intensity. I'm going to put grid intensity on. Oop. Go back down there. And grid intensity. Watch what happens. So now we can see the grids real easy and see what's going on. Okay. So now that we have the injector on here and everything that we should practice, like back at home or in our real world shop, okay, we would definitely want to make sure that we have everything set up correctly. So this UScope here, we're going to come over. Our voltage is okay, but how about our on time? So let's take our soft keys, because we're highlighted here, move over and play with the time. Once the box is lit up, I then could go down and notice I'm down to 1 millisecond. But what happened to the other part of my signal? Well, we could do a vertical adjustment, okay? But I also know we are at 10 volts trigger. So when I'm at 10 volts trigger here, I'm going to take this, highlight it, and before I do that, I know slope. It's going on the upper slope. I'm going to take this and go to the downslope. Because see this line of voltage? That's system voltage. We would like to see as it goes down and the computer supplies the ground. So what I'm going to do here is I am going to change this. And what just happened to our picture? Take a look at that. What just happened to the picture? See, I'm playing with the slope. That's positive slope, negative slope. Okay, very important. And if I raise it up, you see how I can come across the screen? Okay, now if it goes off, I need more time. So I'm going to go over here and make this 2 milliseconds. That way when I raise it up, I could see the whole screen. Okay. And now if I wanted to measure this, okay, well, we're on this first grid here. I don't like going all the way to the bottom. We're at 35 volts on our peak voltage. So let's measure this. Let's show you how to use the cursors here. We talked about them. We looked at them, but now I went to menu, selected cursors, and what I'm going to do is I am going to hit OK. I'm going to put the cursors on. And now both cursors are on. Now you may be going, well, it's a little hard to say. Well, yeah, let's take the vertical one first here. Oop. Sometimes quick fingers will knock you out, but no big problem here. We're going to take the cursor, and they're both on. And we're going to move it if I can find out where it is. Sometime up there, it's right here actually. So this is the vertical one here. I'm going to move that back up. So that'll be to the tippy top. It's right there. Then I'm going to go to the next cursor, and this should be near the bottom. And you see how that went up? It's moving the lines away. Well done. Okay. And now we got a reading on that cursor, okay, which is 34.8 volts from the ground to the top. Then if we go down and we want to do time, horizontal cursors, okay, we take this, I move one over here. This is where the voltage, system voltage, gets pulled to ground. And depending on the angle you're on, to me it looks okay. Here, I'm going to take the next cursor. I'm going to move that over. You see it coming over. And now this is going to be our injector on time. And our injector on time is 10 point something milliseconds. And of course, if I pull this in, well, that's going to change. So what do I need to do? I need to move that cursor over. And right there, I am now at 5.36 milliseconds. So real easy to see, okay, real easy to use. I'm not a big cursor guy. When I have the grids in the back on and you know what each grid is actually worth, okay, then you could just go 2 milliseconds, 4 milliseconds, 6 milliseconds, whatever, okay. That'd be an easier way. Grids, you know, putting cursors on is not my favorite thing to do, okay? So now we can see we got a good signal, but I want to show you something, and we're going to revert back to this a little later on as we go through. I want to get over to voltage, and I want to take this voltage and down it. And I want you to take notice here. Yeah, we went off the screen, but I want you to look at the bottom of this. Now it's bouncing all over the place for a few reasons. Okay. Let me move this over a bit here. Play with that time. And then I'm going to do a position move. That means I'm moving this down. And I'm going to see if I can get down here more on the voltage, because the lower I go is really going to shape something. We're also going to play with the trigger I have highlighted here. And there's the line moving up for trigger. All right, a little hard to see here. So sometimes a preset locks you in where you won't get the finest move out of anything. We could do it a couple of ways, but I just want to show you something. It'll show how fast it boots and how it always goes back. Look how fast I booted up, and it's always going to go back to 1-to-1. And we can see this here. Let's go over to the voltage level. Let me bring that down. And then let me move this over here to position and see if I can position that baby down. Let me go over it, maybe invert it, may help. And that didn't help. Play with position a little bit. And we can start to see the top of the signal. Okay. So this is actually the bottom of the injector, and I am on very, very low voltage here. So my voltage is highlighted, and right there I was able to do it. Can you see that this, and especially if I do this, could you see the bottom of the injector looks like a current ramp with the pintle bounce? And that's because this is actually the bottom of the injector. If I put an amp clamp on that, it's going to look very similar. Now, to show you what you're really looking at, just in case you don't know, I am now going to go up with the voltage and show you the actual injector, right? So there's my actual injector. And remember, the lower we go, the bigger the picture gets. The higher we go, the picture gets real small. Now we're on the 10-volt scale here. When we're bouncing around, okay, what we need to do is take this trigger level here. So we're going to take trigger, and you notice I'm at 20 volts. I'm going to bring this down. The yellow line will come down. I like it at about 7 or so, and you're going to see it's going to be nice and steady. Now, we could hit position here to go up or down, or if we go to menu, we go on the horizontal. That'd be right there, okay? We could play with this, and we could play with that. Let me get that position in there. We want to be on position, not just time. Go down, and now when I move it, I can move this over right here. Why would I want to do that? So I can measure my time easily, okay? So it is really an easy setup to do. It's a lot like a fuel injector. Well, it's very similar. Excuse me, still being sick here. I'm going to switch over and change this time here for you, okay? And now I think you can see a pretty good ignition signal. I will move over to adjusting this voltage so it'll be locked in a little better. We'll try to make it as steady as possible. Sometimes that means you got to go high. Because here's our spark line. spark line here if it's like a nice slope like this. If it was up sharp high, that'd be a lean condition or a wide gap. If it's down, that would be a closed gap on the spark plug or a rich condition. 3 coil humps should be here. And, you know, again, if you want to make that more pronounced, what we're going to do is move over here and try to play with that time frame. And playing with it, I think you can see it a little better. You can see how the line is on a decent slope. The coil oscillations, there's like 3 little humps there. And if we close it up somewhat, and now we're going to move it over, I'm going to go to position, and we'll go to horizontal position, go to menu, horizontal, and we're going to try moving that baby over a bit so we can see the electronic closing. This is dwell, the amount of time that the coil is saturated before it fires it. This is called the firing line right there. From here to here, it's almost like pulse width on time. This is coil saturation on time. So we could do actuators with this. We just did 2. We did a coil just now, and we did the fuel injector. Now let's switch over to a sensor. I'm on an oxygen sensor, but of course my voltage is way out of whack. You see a little line here, but you don't see a bunch of stuff going on, right? So what do I need to do? I'm already on voltage. I need to lower this voltage because an oxygen sensor is roughly going to be 1 volt total, right? And see the line going up and down, rich, lean, rich, lean? Well, we also got to change the time, and probably will have to go up more than 100 millivolts here. So I'm going to play with the time, and you're going to notice it's going to start sweeping. Ah, there you go. So we got to go back here to voltage, come up a little bit, and there's your oxygen sensor. If we go rich, and you see how the signal is going up and down, right? If we raise it up, see how that went rich? And now we got a lazy or slow oxygen sensor. You always want to check an oxygen sensor at about 2,500 RPMs. You'd like it to go at least from 150 millivolts to 850 millivolts. And the faster it does it, the better. Okay? So this is a good signal of an oxygen sensor waveform. We can go to a map sensor, and now the voltage is totally different. But don't worry, we're here on this box. All we need to do is go up, and maybe 2 volts per division, we could change this. And you see how that goes up and down? This would be at idle, with the engine just idling. A map sensor usually goes from 0 volts to 5 volts, right? But the normal range at 18 inches of vacuum is going to be somewhere from 1 volt to 1.7, depending on the year and make of the car. And if you race it up, pedal to the metal, you're going to get near full 5 volts. Now, if we go over the time, this is an analog signal, and I change the time to 2 milliseconds, I want you to look at this line just going up and down. See that? Up, down. Okay? Up, down. That's all it'll do. If you want to see a map sensor fail, well, you're going to have to go to time here and make that about 200 to 500 milliseconds. That way, when I do this, you see how that went up? And again, if the picture is too small for you, why is it too small? Oh, gee, you're on 2 volts. Yes, and what would happen if I went to 5 volts? Well, I'm going to have to take my magnifying glass out is what I need to do. That's a little too small for me. If I go to 1 volt, now I can see way better. So that's a map sensor, or a throttle position sensor would do the same thing. Let's look at a crank sensor signal. Now, crank sensor signal obviously is going to be at a totally different time rate. This here is like the #1 reference. So what we want to do, 1 volt may be okay, but maybe go to 2 volts, and let's change the time so we can see the signature of the signal. And notice there's our square wave. Now, you're not getting something here because of how we're maybe triggering it, or we may have to move it. So we could try changing slope. You know, does it go from a positive slope down? Well, yeah, it does. So let's leave it at from a negative up. And we want to move this horizontally, so we got to go right here to menu, hit menu, and into horizontal position, and move it over. Now we can see it's starting to draw from the bottom up. And if we don't like that, if we want to change the position of that, we go to slope, change that, and we can see. Now, when it bounces around a lot or walks, notice where we're at, 7.2 volts. If I go way above, notice, #1, the UScope warns you, you're out of the range. If I bring this right down in here, right into the middle, look how nice and steady I am, okay? So that is a crank signal. And of course, if we raise it up, the crank signal is going to change, okay? If we go to a cam signal, and now we're on a cam signal, okay? And we could bring that cam signal up by moving to position, and I can bring that up, okay? And notice how it basically is taking the trigger with me, which is pretty neat. If I go back over to trigger and I change this level, you see how it's walking across the screen? I want you to make sure you understand. This is even a question on an ASE test. When a waveform walks across the screen, your trigger level is not set correctly. I like usually going half of the voltage waveform. So right here, what you're looking at is it's walking. The UScope is showing us it's in red. I'm going to lift this up. I'm going to go to half the voltage. See the yellow line right there? And I'm perfect. If I want that to be a little bigger, what do? Come down with the time. That makes sense? So that is pretty simple stuff there. Now, you could do a lot more with this particular setup, okay? It's pretty neat. We could go back again to this inexpensive test board. I'll shut this off for a second, and we'll get back to that. And we could go to a general type sensor here, just to show you don't need to purchase something expensive, right? And this is pretty neat that we can see, move that out of the way, that we can change the frequency. You can make it nice and big without adjusting this, or go and make it tight. So it is something that can be done quite easily with the UScope. The UScope has a whole bunch of powerful features that you could put on or off. You can use an amp clamp. You could use a ignition setup, and we're going to be using this amp clamp, okay, since I don't have the one AESwave cells. Mine broke a while ago, and I've been using this one. So we got it on a 20 amp scale. I'm going to unplug these here, And the nice thing with George's lead sets, or AES's lead sets, is you have this part that plugs to the top. But I could just take these and plug this right into the back here, and now my amp clamp is on. I'm going to take the amp clamp and I'm going to go around the coil, or let's do the injector first. I'll go around the injector. So one of the things you always want to do is see if you have a knob that turns. This one don't. It's just a press. It looks like it turns, but it don't. Okay. So we want to go into current here. We are on 1-to-1 voltage. Okay. So what are we going to do? We're going to go to menu. We're going to hit OK. We're going to go down to probe calibration. And that's hitting the voltage thing. Go down to probe cal. And we're going to watch this change here. Okay. Now, when you see WPS 1, 2, 3, or WP, I should say, that is for pressure transducers that you can do on this. You can do cranking relative compression on here. Okay. So I'm not going to use 100-to-1, 10-to-1. Okay. We're going to use a 1-to-1 amp clamp and see how that goes. If that doesn't work real well, let's see something if I went back one. We're going to use the 10-to-1. Why? Because it puts me on a 20 amp scale rather than on a 2000K amp scale. So we're going to put that right here. I'm going to hit OK. We're going to go back to the test board. We're going to put it on. I'm going to take my amp clamp, zero it, too high of a scale. Okay. If we go back into that calibration, we can go through all the signals here. And if I don't see anything, I'll just leave it on that 10-to-1 and then come down here and change that reading. So I highlight it. You notice something's popping up. Look at that. Okay. So I want it a little bigger. There I go. Now I am on the injector waveform. If I want to move this over, position, get it down. Okay. And you remember how the bottom of the injector looked? This part right here? We are actually reading the current. Now again, this being a test board and a coil is right next to the injector on this board, you're going to get a little bouncing around, but that's a pretty damn good signal. Now, if you wanted to do other measurements on this, we can go over the menu. We could go down to meters. And we could see a whole bunch of different numbers here going, right? So we could see the upper amperage or the min-max type setup. That's pretty neat, okay? So there's a lot you could do with the UScope. You also should be aware that I could take the soft key here, move it over, and if I want to hold something, I could hold it. If I want to set up normal or auto, I could do that as well. And if I want to save something, I could go to menu, hit that, go down to where there is even files, and then I could save as a image, so I can do that right here. Notice, saved. And if I want to save the waveform setup, I could go here and save user. And then it's going to tell me which one I'm in. And it saves it. Pretty neat. Okay. And again, if you want to move this horizontally, you can move it vertically from here, but horizontally, and the more you play with it, you can get this thing to really work super well. You see if I go too far, it's off the screen. I just went all the way that way. You see the green line coming in? And if I want to move it right to there, I can. Hit OK, and you're off the screen. If we want to look at the ignition coil now, that was the injector I was just on. I'm going to go on the coil. You got to make sure the jaws are totally closed. Now, you don't see the signal. You know why? The amp clamp is on upside down. So I'm going to take and move to invert. Going to hit OK, and there you go. Now, if I want this wider, not a problem. I come here, and I just drop that down. Remember, lower numbers, make it wider this way. Lower numbers on here are going to make it bigger off the screen. Higher numbers, make it real small. Okay. So the UScope is a powerful scope that basically has a lot of great features. It saves stuff on the bottom here to a little mini SD card. You could take that, put it into a computer to download the files. They do have at AESwave.com. They have a user manual on it to go through. It's not hard to work. Even the other day when I was coughing my brains out, feeling like total badness, that I was still able to operate the scope somewhat. I am filming this part here to fill in between all my coughs I had there, okay? And we would love to hear your feedback on the use of the scope. Again, the big thing here is practicing, okay? Practice makes you a better scope user. If you practice on one of these inexpensive type of boards, that's great. Or if you want to buy an expensive board, that's good as well. Okay, those are all good things to do. Then you got to take it to the car. Maybe in an upcoming Dorman Lunch and Learn, maybe we'll do one on the car with cranking compression and showing you on, these are simulator boards, right? But on real vehicles, what it does. But a great tool, and I thought this would be good to help you guys that are users of scopes to make yourself better, and those that are not scope users, okay, well, hey, now you could be a scope user, because this is, number one, inexpensive. Every technician could buy one of these. The kits that come with it, this is the basic kit here. It basically has the lead ends that you've seen, okay, a little setup here in user guide, and it has a little boot. I left the boot off so it'll be easier to stay up here. The tape didn't like the boot, or the boot didn't like the tape. Whatever one, it didn't matter. We didn't use it here. You could also purchase the secondary ignition setup, okay? And by the way, this can be used, these connect ends here, like this paddle, you can use it on other AES connectors, and this paddle works pretty good. You put it next to a coil, and it comes up with a signal. Make sure, you see this big ground, that when you use this on a vehicle, it's always grounded. And that's maybe what we'll do in another upcoming Dorman Lunch and Learn. Let's get back to the slides. I just think the reason why I wanted to put this together, excuse me, and I apologize on not doing such a great job today, in my opinion, but I want you to be aware of how you can use a little tool like this to upgrade your skill, okay, to upgrade your skills in diagnosing stuff with a scope. This is a great place to start, I think, Now, again, I didn't look, but maybe someone else out there knows. I think this is under $200 for the basic scope kit. Okay. That is pretty incredible. Okay. For guys that don't own a scope, many technicians out there can't afford a scope. You can use this not only on a practice board. I am going to use some of this out on a vehicle tonight. Yeah, unfortunately, yes, I have to work tonight, but I don't have to yak as much. Thank God. Tonight is our TST monthly meeting. Tonight we have Jeff Zide. If you have an eScope, or even if you have any scope or thinking about buying a scope, you may want to check this out at tstseminars.org. We got a load of people signed up. Jeff does a great job. It's using a labscope. We have upcoming instructors next month. We got the great Bernie Thompson, followed by John Thornton, Scott Manor, Bill Fulton. We go all the way out to June. Do want to say this, the TST big event, and thank you, Dorman Products, for being one of our major sponsors. March the 18th, excuse me, in Terrytown, New York. That will be our TST big event. We have Keith Perkins, Gary Smith, and a mystery special instructor. We give you hot breakfast, a hot lunch, and dinner and drinks at night. You can hang around. The after party starts this year from about 6:30 to 9:30 or so, and all the food and drink is free, and you can win a lot of stuff, a lot of prizes and all that. So I want to thank you for coming out. If you have any questions, put them in there. I'll probably get back to you. I'm going to have to take a little breather break here in a minute. But I do want to thank you for coming out. If you think this information was helpful, it could have been a lot better. Type the letter Y in. If you think it sucked, type the letter S in. I was sorry if you felt your time was wasted. I always thank you guys for coming out for the Lunch and Learn. We'll see you next month on the Lunch and Learn. From New York, a sick G. Trulia. But happy Thanksgiving to you and your family. And thank you again, Dorman Products.